Hello everyone, welcome back to yet another video in my channel. In today's session, I have brought a very interesting topic that every non-tech guy would be interested to know about. The topic is about three words that you almost keep hearing in almost every IT projects. Those are front-end, backend, and middleware. They are simply three parts of a software system. Think of any application you use, like your mobile banking app, Amazon app, Swiggy app, Netflix, even your office portal. You see a screen. You click buttons, something happens behind the scenes, and result comes back. That entire journey is what we are going to understand today. Especially for business analysts, testers, and non-technical learners, this topic is extremely important. Why? Because when you write your requirements without understanding which layer is responsible for what, you may write vague requirements, and vague requirements confuse everyone in the project, including the developers, testers, and the business stakeholders. By the end of this video, by the end of this video on front end, back end, and middleware, I am very sure you would be able to sit in a technical discussion and confidently say this is a front end requirement, this is a back end requirement, this is back end validation, this needs middleware mapping, this error must be handled at the API gateway, and this flow need a sequence diagram. With that, let us start with the easiest example of a restaurant. Okay, so when you enter a restaurant, what do you see? You see the dining area. You see on the dining area, you see the menu, the table, the ambience, the stuff, uh, the picture, maybe a nice picture of food that looks better than the actual food. This visible experience is what we call the front end. In the software world, front end is the one that gives you the screen, button, forms, messages, and layout that the user interacts with. Now, where is the real work happening? In the kitchen, right? The chef, the real work is happening in the kitchen. The chef checks the order, prepares the dish, combines ingredients, follows rules, and finally produces the food. That kitchen is the backend. In the software world, backend is where actual business logic happens. It validates a request. It applies the rules, talks to the databases, and returns the results. But how long? But how does the order go from dining area to the kitchen area? Definitely, it's through a waiter. Somebody has picked that order and taken it to the kitchen. So the waiter takes your order, checks whether you asked for any extra spicy item, sends it to the kitchen, follows up, and brings the food back. This is your middleware in the software world. So middleware connects your systems. Um, it routes the messages, translate formats, and coordinates the flow. Now that we have understood the simple analogy, let us try to convert it into professional language in our in the enterprise context. So front end is the client side layer. Client side means it runs on the user's device. It could be your mobile, it could be your laptop or desktop. Okay, it could be your browser. So ultimately, the job of this front end is to render the user interface. That is, display the user interface, handle the user interaction, and present the information clearly. Coming to the back end is the service side layer. It runs on the servers, your cloud platforms, containers, or even the mainframes. This is where the business logic. This is where the business logic, data processing, integration, databases, API exposure happen. Coming to the middleware is the integration layer. It may sit between your front end and back end. So this is for front end, and this is your back end. Your middleware sits somewhere between this two. So or it may also sit between multiple backend applications. So multiple backend between multiple backend application also there could be middleware. The job of this middleware layer is to route, transform, orchestrate security logging and error handling. So if you are in an interview, define each layer in one line, and then immediately try to give an example. So that will increase your credibility. For example, in a mobile banking, the balance screen that you see is the front end, the balance calculation and the data retrieval is the back end, and the API gateway that routes the request is the middleware. So that answer sounds simple and mature. This slide shows what usually lives inside the front end layer. So imagine the whole front end as a imagine the whole front end as a building. At the top floor, this is the top floor. Just assume this is the top floor. At top floor, it is the browser or it's a mobile app itself. That's a container. Everything else lives inside. The most visible things within this browser of app is your UI components. So these are your building blocks. Your UI components are your building blocks. For example, the login form you type your password into, the card showing your account balance, the table of recent transactions, the navigation menu you have on your browser, the little red alert banner when something goes wrong. So each one of this is a component, reusable piece of visual interface. Now behind those visuals, there are six important mechanisms: state management, client-side routing, input validation, API client layer, or token storage and error and loading steps. So state management, think of this as a uh, apps working memory. It tracks who is logged into the application right now, which account are they viewing, what have the user selected. Without state management, every click would feel like starting from the scratch. That's why it's called apps working memory. Client side routing. This is what lets you move between. This is what lets you move between pages in a application without the whole screen going wide and reloading. So when you click transactions, for example, and the page updates instantly, so that's client side routing. Okay, now input validation: before your app even contacts the server, it checks the basics. Is there a real email address? Is the transfer amount a positive number? So that instant feedback comes from the front end validation, also called input validation. API client layer. So once you have logged in, the app holds a small digital key, usually called JWT or JSON Web Token, that proves who you are. So every request carries this key, so the backend knows it's you who is asking. Then error and loading states. Error and loading, those spinning circles while your page loads, right? That then something went wrong, please try again banners, the retry buttons, all of that is deliberately designed and will. It does not happen automatically, so someone has to specify it. That someone can be you, or that someone can be the developer. So that is something called error and loading states. And at the bottom of this diagram, uh, so is a HTTP API calls. So all communication with the backend happens through HTTP API calls. The front end never touches your database directly. It must make a request and then have to wait for the responses. Now you do not need to become a front end developer, but you should recognize the common technologies used for the front end changes. For example, for the modern web, there is a React. So React, is a very common in modern digital application. it builds screens with reusable components. It builds screen with reusable components. That's why this is very popular nowadays. Angular is popular in the large enterprise portals because it gives your structure and consistency. Vue also is there. So Vue is lighter and often seen in fintech and internal tools. For mobile application, you will mostly be seeing React Native, Swift, and Kotlin. React Native allows team to write one code base for and run it on both iOS and Android. Now Swift is used for native iOS app. Kotlin is used for Android app development. So native apps are preferred when the device integration when the deep device integration is needed, such as biometrics, your camera screening or secure storage. Now coming to the legacy banking system, you may still see this JSP, JSF. These are server rendered technologies. The server creates the HTML page and sends the full page to the browser. Okay, now let us discuss the rendering thing. So what does rendering actually means? By rendering it means how the screen gets created and displayed. So there are two types of rendering. One is client-side rendering and the other one is server-side rendering. So in client-side rendering, the browser downloads a basic shell and the JavaScript. Then JavaScript will call the API, receive data, and builds the page in the browser. So React and Angular single page application commonly work like this. The first load may take some time, but once loaded, navigation can feel fast. In server-side rendering, the server builds the full HTML page and sends it ready to display. This gives a fast page load and is useful for SEO. Traditional Java pages and modern frameworks like Next.js can use this approach. Now, why is this important to someone who is working as a PA or someone who is working as a tester? Because where the screen is rendered can affect where rules are applied. For example, if a promotional banner should appear only for the gold customer, do you decide that in the front end based on a token, or does the backend return a flag like show promotion equals true? Okay, so sensitive business rules must be enforced on the server side. That's a note for you. Sensitive rules must be enforced on the server side. The front end should only be used to guide the user, but the backend protects the business. So never trust the browser as a final authority. Okay, now this is one of the most important topics under this session: front end validation and the backend validation. Suppose front end validation is for is this particular validation is for user experience, whereas backend validation is for data integrity and security. So coming to the front end validation, suppose the customer enters ABC in the amount field. The front end can immediately say, please enter a valid amount. Okay, this saves your time and avoid unnecessary API calls. So it is quick, friendly, and helpful. That is what we mean by front end validation. Backend validation is for your data integrity and security. It runs on the server. It is the final authority. Your backend is the final authority. Why? Because front-end checks can be bypassed. A user can use tools like Postman or scripts to call the API directly. So if the rule is important, the backend must enforce it. Let us take an example. For a transfer form, The front end can check whether the amount is numeric, whether the account number is say of 8 digits, but the backend must check whether the customer owns the source amount, whether sufficient funds exist, whether daily limit is breached, and whether fraud rules are triggered. So that's why backend is very very important from the rule perspective. Okay, now let's move to the backend part. So backend layer is something is also called the brain of the application. So when the customer clicks, say for example, on a application having transfer fund as a button, when customer clicks on transfer funds, the front end sends a request. The backend will receive it and starts doing the serious work. First, it will validate the request. The backend will validate the request. It will validate like is the amount positive, is the account number present, is the customer authorized. Second, it will execute the business rules. Does the customer have sufficient funds? Is the daily transfer limit exceeded? Is the account frozen, or is the payment suspicious? Okay. Third, it will call the other services. So it may call account service for balance. It may call fraud service for risk check. It may call beneficiary service for account validation, and notification service for alerts. Fourth is it parses data. Persisting means it is storing data permanently, such as writing a transaction record into the database. Finally, it returns a response to the front end. Maybe it's a success or failure or pending. So these are the 5 steps. Every time someone taps pay on the phone on the UI, something like this happens on the backend in milliseconds. So when someone says backend, just do not imagine one mysterious black box. Imagine a rule processing machine that validates, decides, coordinates, stores, and responds. Now let's try to zoom into the backend. It's not just one monolithic blob of code. It's actually organized into layers, each with a specific job. So at the top you can see it's a there's a controller, or it's a API layer. This is the just imagine this as a receptionist. It receives your incoming HTTP request. It checks the format. It unpacks the data. And then it passes it inward. REST endpoints live here. For example, the URLs may be there for your front end calls like post, payment, transfer. Then in the middle is a service or business logic layer. This is the brain. This is the brain. This is where your rules will live. For example, it checks the sufficient funds, enforce daily limits, call fraud engine. So as a BA, this is your territory to actually understand. When you write acceptance criteria, you are describing what this layer must do, okay, to suit your scenario. Then below that, there is a repository or data access layer. This is like a librarian. This is like a librarian. It knows how to read and write to the database. It abstracts away the SQL and database specific details, so the services layer does not have to care. At the bottom, we have the database. So this is where everything is stored. It could be relational, document, event source, and so on and so on. So when you write a requirement, uh, when you write a requirement like transfer must fail if available balance is less than amount, try to ask which service enforces this rule. Is it payment service or account service? Does the existing method already calculate available balance? This question show technical awareness without presenting or without be like a developer. Now let's try to look into the technologies that are used in the backend. So one is Java. So Java with Spring Boot is extremely common for enterprise backends, payments, and core services. Many REST APIs are built using your Spring Boot. Then when someone says we are building a REST API, it is often Java underneath. As a BA, you will be able to review API contracts in the YAML or JSON. format. Then we have C or .NET. These are common in Microsoft Stack, banks, and treasury systems. Architecturally, many concepts are similar to Java. If you see Azure everywhere, you are probably into a .NET area. Python. Python is less common in transactional system, but dominant in data related stuff like data pipelines, your risk modeling, then machine learning. If your project involves predictive analytics or some AI, you can expect Python in the backend. Then you have Node.js. Node.js is very popular for API gateway layers and real-time features like real-time notifications, push notifications, and very good at handling many good at handling many concurrent connections. Then we have COBOL. COBOL may sound ancient, but in banking it is still not that. Many core banking and mainframe systems still process millions of transactions daily using on COBOL. COBOL on mainframe still processes a significant portion of world's financial transactions every single day. If you work in a heritage bank, you will encounter it. Um, as a BA, you should know that business rules buried in the COBOL stored procedures are some of the most business critical in existence today. PL, SQL, T-SQL are used inside the databases. In legacy systems, business logics may be hidden in a stored procedures. This is important because sometimes the rules are not in Java code. It is buried in the database like treasure says like a treasure. Nobody wants to open. So as a BA, always ask which are any rules implemented as a stored procedures. So, but as a BA or a TESA, you do not need to code in all these languages. You just need to know where they live and what questions to ask. Now, this one is very important for becoming a technically credible BA or technically credible tester. So I want to be very clear about something. You do not need to be a developer. Actually, you are not going to build code like this. You are not going to debug it. You are not going to test on you are not going to be tested on syntax, but you do need to read the logic well enough to ask good questions. Let me just show you what I mean. So this is one pseudocode in front of your system. uh, Here the system gets a cleared balance, then it gets a pending debit, as you can see on the code. An available balance is calculated, then it returns true if available balance is greater than or equal to transfer amount. So a beginner BA may look at this and say, okay, that looks a bit technical, but when you become a strong BA or you are acting as a strong BA, you should say, wait, does pending debits include your card authorization? Is overdraft considered? What about the currency? What about the joint accounts? What about uncleared check? So this is how you catch gaps between before they become the defects. For example, if a customer has cleared balance, let me just write here cleared balance as 1000, uh, pending debit of 300, transfer amount of 800. So your available balance as per this formula becomes 1000 minus 300, that is 700. Now, in this case of logic, since available balance, the code should return only when the available balance greater than transfer amount. Since in our case, in my example, available balance is less than 800, so the transfer should technically fail. Okay, so that's how you need to interpret the code or the logics. Okay, now we have looked at front end, we have looked at back end. Now let's look at a middleware part. So, and middleware is the most misunderstood layer. Users do not see the middleware. Product managers, even product managers, may forget middleware, but enterprise systems cannot survive without this middleware. These are the connectors. Okay, middleware is the plumbing of enterprise systems. So it connects your applications that speak different languages. It connects your application that speaks different languages, different protocols, or and store data in different formats. So imagine a multinational bank. One system speaks ISO 20022 XML message. Another system expects empty format message. A third system may expect proprietary fixed length file. Now middleware here in this case will act like a event interpreter. So it receives the message, validates the message, and then transform it, route it, and logs it, and then handle the error. So in banking, middleware may convert your ISO to empty, MX to empty, route message to the Swift gateway, and send data to fraud systems, push update to your reporting databases, and place failed message into a dead letter queue. For a BA, middlewares matters because integrations requirements live here. Your field mapping, message format, transformation rules, routing logic, retry behavior, error handling, and mentoring. Okay, there are four main middleware patterns you will encounter in banking. Mostly, let's take one at a time. First is your ESB or Enterprise Service Bus. It is a central hub. It is a central hub. Systems connect to ESB, and the ESB routes and transforms the messages. So tools like your MuleSoft, uh, IBM App Connect or MQ, TIPCO, Oracle SOA. So this are tools that interact using ESB. ESBs were the dominant patterns for almost 20 years, and I think you will still find this ESBs everywhere in the banking projects. Second is your API gateway. API gateway. This is the front door. This is the front door. This is your front door for internet and mobile traffic. So when a mobile app sends a request to the bank, it first hits the API gateway. The gateway will check your token, enforces rate limits, and identifies who you are, and then route you to the right backend service. So think of it as a very security conscious hotel receptionist. Now, third is your message broker. So this is for use for asynchronous communication. Rather than system A calling system B directly and waiting for a response, system A will put a message on a queue. Will push a message on a queue. System B will pick it up when it's ready. When the system B is ready. Now this is incredibly powerful for high volume resilience critical flows. For this, the tools like Kafka, IBM MQ, Rabbit MQ, Azure Service Bus are used. Then we have the fourth is BFF. So BFF does not mean best friend forever. Here BFF means backend for front end. So this one is a modern pattern, and it comes up a lot. So different front end channels need different data. Your mobile app needs a lightweight response. Your web portal might need a richer, paginated, more detailed response. So rather than the same backend API trying to serve both, a BFF is a thin tailored API layer built specifically for each channel. So now if you try to look at the difference between these four, so the simple difference means the simple difference here is ESP connects your internal system. So it basically connects your internal system. API gateway, this API gateway protects and helps in routing external API traffic. Then message broker supports your asynchronous communication. and BFF saves your backend data. It saves your backend data for UI, for better UI experience on the front end. Now let's try to zoom into the BFF for a minute. So BFF, as you know, backend for front end, because this one has a direct impact on how you write the comments. Suppose your bank has a mobile web, your bank has a mobile app, um, and a web portal. Both need account information, transaction, and offers. Okay, but their needs are different. So mobile app is a small screen, so it will likely be on a slow mobile connection. It needs just what it needs: account number, it needs current balance, last three transaction, maybe an offer flag. So six fields, maybe let's assume, which need to be displayed clean and fast. The web portal has a full desktop view. This has a full desktop view. It needs full account details, all transactions with filters and pagination, offer recommendations, linked accounts, domestic downloads, and many more. So it may potentially maybe 30 plus fields we need to display on a web portal. So if you build one backend API to serve both mobile app and web portal, you are either overloading mobile with data that it does not need, or starving the web portal. Okay, the neither of the approach is right. So with a BFF or backend for front end, the mobile app talks to the mobile BFF. The web portal will talk to the web BFF. Each BFF calls the same underlying services and aggregates, but aggregates and the formats the response differently for different channels. So it will show what it is required for the mobile, and will show what it is required for the desktop application. Now, okay, this is an interesting one actually. We let's see how a single user action flows end to end. So take an example of a customer sending or initiating 500 pound on a mobile banking app. So let's go. Okay, it will start. Let's start with step one. So let's for step one we have the front end. We are on the UI. So the user will fill in the recipient, account number, amount, reference, and all. The front end will validate the front end format instantly. Whatever the amount is must be numeric, short code must be 6 digits. Everything checks out. The front end attaches the user's JWT token as well, and fires a post request to the payment transfer. That request is now traveling over HTTPS to the API gateway. Okay. Now the gateway will catch the request, validates the token. That is whether the person is you, is the session still active, check the rate limits. So haven't they sent too many requests today, and so then that way it identifies a customer. Then the API gateway will route the request to the payment service backend. The payment service will parse the request it receives from API gateway, applies business rules in sequence. Does this customer own this account? Is the transfer within the daily limit? Is there sufficient available balance? Is the beneficiary well dated? All of this are your acceptance criteria in action, for example. Then the payment service will call the account service to confirm the balance and execute a debit and credit simultaneously, or in a sequence. It will call the fraud API or fraud service. Is this transaction flagged as suspicious? If the fraud returns a block, the payment stops here. And then once the payment completes successfully, an event is published. For example, a payment completed. Okay, so downstream system will consume this event asynchronously. The notification service sends a push alert. The ledger will record a transaction. Analytics system will update the accounts. Then it will come to the response. Again to the front end. So the payment service returns HTTP 1201 created with a unique transaction reference. The API gateway then passes it back to the front end. That is, again we are coming to the front end. The front end basically displays that your payment is successfully posted. That's what it will display to the user. So the entire end-to-end flow involves this 6 step. So this happens in a every time, in a fraction of second and millions of times a day. So this flow is the heart of techno-functional understanding. As a BA who understand this can write better stories, better acceptance criteria, and better test scenarios. And with this, we come to the end of this video. This was all about your front end, back end, and middleware. Hope you were able to understand the concepts now and able to interpret the system layers in a better way. So if this video has helped you, please do like, subscribe my channel, and share your comments and feedback in the comment section. Keep learning, and see you in the next video. Bye.